Hi, Assalamualaikum and good morning everyone and Puan Tenten. Today we will present about engineering mathematics 2. In topic 2, differentiation. Start. Hi and good morning to madam. So this is my group member. First is Izul Huzaimi bin Muhammad Zaidi. Metric number is 08DJK22F1002. And the second is Muhammad Firdaus bin Abdul Talib. Metric number is 08DJK22F1026. And the third is Irfan Izzuddin bin Zulkifli. Metric number is 08DJK22F1019. And the last is me, Muhammad Aidil Satria bin Azmi. The metric number is 08DJK22F1059. Introduction to differentiation. First, differentiation is all about finding rates of change of one quantity compared to another. We need differentiation when the rate of change is not constant. Second, differentiation in mathematics, the process to find a derivative or rate change, a function. In contrast to the abstract nature of theory, on the contrary, manipulation using some basic derivative for operation rules and a knowledge of how to manipulate functions.
So, hi, my name is Yusuf Huzaini bin Muhammad Zaidi, holding metric number of 08DJK22F1002. So today I'll be explaining about 2.7 application of differentiation. So as we all know, differentiation is widely used in science and engineering field. It can help us solve many types of real-world problems. Some of it include tangent and normal, Newton's method, rate of change, finding maximum, minimum point, and curve sketching. So, as you all can see, there are three types of point. So, first type is maximum point. So, we can see the shape of this graph is concave down. So, uh, 2 square y over d square y over dx square is negative for this maximum point. And second one is minimum point. So the shape of the graph is concave up. And d square y over dx square is positive for this graph. And the last one for the point is stationary inflection point. So the shape of this graph is curvature changes. So d square y over dx square is 0 for this graph. Okay, so we're moving to the next slide. So as we all know, we must understand that stationary point only occurs when dy over dx is equals to 0. So in order to determine the stationary point is a maximum, a minimum, or a point of inflection, we must apply the second order derivative. So there are three of it. So first one, we can see if d square y over dx square is more than 0, so that means it is a minimum point. Second one, if we see it's d square y over dx square is lesser than 0, it means it is a maximum point. And last one, if d square y over dx square is equals to 0, it is a point of inflection. Okay, so that's all from this slide. We're moving to another slide. Okay, so for this slide, I'll be telling you guys about how to sketch the curve graph. So here are some steps in sketching the curve. So for the first step, we need to find the stationary points. Second, find the dy over dx and put it equals to 0. Third, we need to solve the resulting equation, as we can see there, to find the x coordinates of the stationary points. Fourth, we need to find d square y over dx square and substitute each value of x to find the type of stationary points. Fifth, use the curves equation to find y coordinates of the stationary points. And for the step 6, we need to find the points where the curve meets the x-axis and the y-axis. And the last step is sketch the curve. Okay, that's all from this slide. So we will be moving to the question. So we're moving to the question. So the question is, given a curve y equals to 2x squared minus 4x plus 3. So they want find the stationary point and sketch the curve. So as we can see here, y is equals to 2x squared minus 4x plus 3. So dy over dx is equals to 4x minus 4. So we need to find the stationary point. So for the stationary point, dy over dx is equals to 0. Then 4x minus 4 is equals to 0. X is equals to 1. Y is equals to 1. Okay, therefore stationary point is equals to 1, 1. And d square y over dx square is equals to 4, which is more than 0. Therefore 1, 1 is a minimum point. So we can see the graph. So if it's minimum point, the graph will be concave up. So we can see the graph shape is concave up. Okay, okay, so that's all from me. We're moving to the next person. Thank you.
Next, the question 2. The question is find the coordinates of the stationary points of the curve. Y is equal to x cubed minus 6x squared plus 9x plus 5. Determine their nature and sketch the graph of the curve. Okay, the solution. Y is equal to x cubed minus 6x squared plus 9x plus 5. Then dy over dx is equal to 3x squared minus 12 plus 9. x1 is equal to 3 and x2 is equal to 1. So in bracket x minus 3 and x minus 1. When x equal 3, y equal 3 cube and minus 6 in bracket 3 square plus 9 in bracket 3 plus 5. When x equal 1, y equal 1 cube minus 6 in bracket 1 square plus 9 in bracket 1 plus 5. So the example is 9. The stationary points are in bracket 5 5 and 1 9. D square y over dx square is equal to 6x minus 12. When x equal 3, d square y over dx square equals 6 in bracket 3 minus 12. So the example 6 bigger than 0. So this is main point. When x equal 1, d square y over dx square equal 5 in bracket 1 minus 12. So the example negative 6 small than 0. So this is maximum point. Okay, therefore at point in bracket 35 the point is minimum point, and therefore at point in bracket 19 the point is maximum point. So the graph we can see in the shape on the graph.
Okay, my name is Irfan Izzuddin bin Zulkifli. My metric number is 080 DJK 22F 1019. Okay, perform application of differentiation in real problem. One of the most important application of derivative in real problem is to calculate the rate of change. It allows to find rate of change of area with respect to time.
Hello, my name is Muhammad Firdaus bin Abdul Talib. My matrix number is 08DJK22F1026. Okay, moving on to the question. My question is volume of the sphere change at the rate of 30 pi cm cube second negative 1. Find the rate of change of its radius when the radius r equal to 4 cm. And given the sphere, the volume of the sphere V equal to 4 per 3 pi r squared. Okay. From the question, the information that we get from the question is dv per dt equal to 30 pi cm cube second negative 1 and r equal to 4 cm and v equal to 4 per 3 pi r2. So the question want to find the rate of change of radius. So it's the r per dt. So to get the r per dt, we get this equation, right? That's it. The r per dv times dv per dt. So firstly, we got a dv per dt. That's it, 30 pi. Okay, and then we then what we want is the r per dv. Okay, we have v. So we differentiate the v and we get dv per dr. That is a per 3 pi r. But the question is want the r per dv. So we convert it. So it's we get 1 equal to 1 per 8 per 3 pi r. Okay. Then we got the r per dv and we also get a dv per dr, a dv per dt. Sorry. So we put it on the equation and we get dv per dt equal to 1 per 8 per 3 pi bracket 4. Why is bracket 4? Because r is equal to 4. So we put it already. Time 30 pi. Using a calculator and we get the answer. So dv per dt equal to 45 per 16 cm second negative 1.
Okay, for example, we have one cube. The volume of a cube is 729 cm cube. If the water level in the cube HCm is increasing at the rate of 0.8 cms negative 1, find the rate of increasing of the volume of water. Okay, the solution is let if let each side of the cube be xcm. Volume of the cube equals to 729 cm cube. X cube equals to 729, x equals to 9. Volume equals to 9 times 9 times h equals to 81h. So dv over dh equals to 81. Rate of change of water level dh over dt equals to 0.8. Okay, the solution is dv over dt equals to dv over dh times dh over dt equals 81 times 0.8 equals to 64.8 cm cube as negative 1. Hence the rate of increase of the volume of water is 64.8 cm cube as negative 1.
The conclusion that we got is to sum it all, Differentiation is not a simple thing to learn. It requires us to have a very deep understanding in this topic and able to solve and understand the problem. This topic also is an important topic in engineering field. It's commonly used in shipping sector that requires many things from this topic to make sure everything works well and no mistake occur. That's all from four of us. Thank you so much.